Everyone. My name's Aman and I'm the GCSE Chemistry tutor. It's lovely to see so many of you back here again today. Today we're going to be looking at the reactions of alcohols and carboxylic acids. So it's a continuation of what we were covering yesterday. This is the last session on organic chemistry with regards to alcohols, carboxylic acids, alkanes and alkenes. If you're wondering what we're going to cover next week, we'll be looking at polymers before moving into electrolysis. So this session will run for an hour, so it will finish at 10:45. And as usual, if you have any questions at all, please pop them into the Q&A function or the chat box. Today, my focus will be on exam questions once we've been through all the content, so we won't have any quizzes today. And the reason for that is that I think it's important that we go through exam questions to cover this topic and make sure that you're all comfortable doing those exam questions. So I've got a range of exam boards that we're going to do exam questions from, but as I said, no quiz today, unfortunately. If you haven't met me before, as I said, my name's Aman and I study medicine at King's College London, and I've done lots of lessons with MyTutor, and I've done all the chemistry online school lessons as well. So let's get started. So today's learning objectives are to know the combustion reactions of alcohols. So we've looked at the combustion reactions of alkanes and alkenes. So the final one you need to know is the combustion reactions of alcohols. We're then going to look at the reactions of alcohols with sodium, as well as oxidation reactions. So remember yesterday we went through the reactions of alkenes, and that was with halogens, with hydrogen and with steam. Today we're looking at the reactions of alcohols with sodium and oxidation, so with oxygen essentially. Then there's a higher tier learning objective, which is to explain why carboxylic acids are known as weak acids. So we'll look at the properties of carboxylic acids, and then the higher tier specific objective is to know why they are weak. And then finally, we'll be doing lots of exam questions as we go kind of at the end to cover everything that we've covered this week. Okay, so as a recap then, there are 4 structures on the screen. So let's try and name them. So we'll start with the red one, so the top one first. Any ideas? What's the top one? What is that? Can we name it? So in exam questions, they don't ask you to draw them out as much anymore. Usually they ask you to name structures. Excellent, so I've had 1 correct answer so far. Any other answers come through? So what structure is the red one on the screen? It's got 3 carbon atoms. Brilliant. Yeah, it's propane. Propane. So 3 carbon atoms, 8 hydrogens. That is propane. It's an alkane. And the reason we know it's an alkane is because it's only got single bonds. So it is C3H8 alkane. Great. What about the blue one? What's the next one over here? So we can see a double bond there. So double bond, 2 carbon atoms, 4 hydrogens. What do we think that is? Brilliant. Everyone that's given me an answer so far, you're correct. So well done. 2 carbon atoms, double bonding with 4 hydrogens. Yep, it's ethene. Well done. So ethene is C2H4. C2H4. Okay. The next one on the screen, the green one, what do we think the green one is? We've got 4 carbon atoms. We've got a different functional group there. We've got a COOH group. What do we think? What is that? So the third one on the screen. Okay, so I'm having a few different answers. Remember, it's 4 carbons. So what does the 4 carbon usually start with? Not prop, but bute. Good. So people that are giving me bute answers, you're on the right lines. Is it butanol or butanoic acid? What do we think? Butanol or butanoic acid? Excellent. It's butanoic acid. And the reason we know is that remember that in an alcohol, all it will have is the OH group, whereas an acid will have the COOH. So this COOH is a carboxylic acid group here. That's how we know it's a carboxylic acid. So this is butanoic acid. And remember yesterday we went through how to label that. So we do it as we draw it. So CH3, CH2, CH2, COOH, like so. Okay, what about the last one then? So this one we have got an OH group. There are 5 carbons. So what is the last one? Great, everyone's given me correct answers so far. Yep, it's pentanol. pentanol. Excellent, well done. And again, to write that out, it would be CH3, CH2, 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 C, not this C there, just OH, like so. So the OH group makes it an alcohol, the COOH group above makes it a carboxylic acid. Excellent. Any questions about any of those? So we went through all the different functional groups yesterday, but any questions about any of those? Okay, great. So the next recap then, I just want to cover esters again. So we went over esters as our last piece of content yesterday, and we said that they're made from alcohols and carboxylic acids reacting together. I don't think I mentioned the sulfuric acid catalyst, but I did say there is a catalyst involved. If you're wondering what catalyst that is, it's sulfuric acid. You're not usually tested on that. It's just if you wanted to know. So let's try and remember what's produced when we react an alcohol and a carboxylic acid. So any ideas for this first one? Methanol and propanoic acid. Which ester is produced when methanol reacts with propanoic acid? Excellent. I've had one answer come in so far. You are correct. Well done. So it's one ester. If I give you a clue that an ester sounds like ethyl ethanoate, so that's an example of an ester. So it's going to be something like that, ethyl ethanoate. Any ideas what the second product is? So the person that gave me the correct product, what's the second product? Good. Yep, the second product is water. Excellent. Brilliant. Yep, so we've got lots of correct answers now. So it's methyl propanoate, methyl propanoate. So just remember that when we're thinking about esters, the first part comes from the alcohol. So methanol gives us the methyl, and the anoate, or the actual carboxylic acid bonds, comes from the propanoic acid. Okay, and the other product is water. So yeah, well done. Okay, what about the next one? Have a look at the way that I've written that word equation. What do we think? So don't let yourself get confused by which way I've written that word equation. I've put the acid first. So that's a clue. I've put the acid first. Okay, it's not butanoic acid. Butanoic acid is what would be kind of as a reactant. So it's not butanoic acid. Excellent. It's butyl ethanoate. Yep. So when I said not to get confused, what I meant by that was that the alcohol is second. So it's really important that you remember the first part of the ester comes from the alcohol. So therefore it's butyl, and the second part comes from the carboxylic acid, so ethanoate. So that was a bit cheeky of me to put it butanol second, but I did that just to make sure that you understand that the butyl comes from the alcohol and the ethanoate comes from the carboxylic acid. So well done to everyone that got that correct. And then the second product is water. Okay, any questions about the formation of esters? Does anyone remember what's special about when we draw esters? What's special about when we draw esters? I'll draw one in just a second, but what's special about it? So if I was going to draw methyl propanoate, what's special? Yep, someone's just said the alcohol comes second. So unlike most structures where we go from left to right, in esters, we almost go from right to left. So if I was to draw methyl propanoate, you might expect it to be COOO, that's our methyl, with a H here. So that would be our methyl. This is what we might expect it to be. And then our propanoate would have our 3 carbons like so. As I said, this is what we might expect it to be. This is not what it is. This is wrong because in esters, do you remember I said that the propanoic acid gives the COO bond? So that means this whole part on the left should be the propanoate, whereas the part on the right should be the methanol or the methyl. So how it should be drawn, so this is incorrect, so I'm going to put a big red line through it so we know it's incorrect, is that it should be drawn with our COO bond. We should then have our propanoic acid here, so our propanoate. Remember, there's already 1 carbon, which will be in the ester bond. So this is our ester bond here. And then the other carbon here. So that is the propanoate. And then we just need the methyl, which is just 1 carbon. So that is the correct structure of methyl propanoate. So as someone said, the alcohol goes on the right, not as we would expect. Someone's asking, why is it always ethanoate? It's not always ethanoate. So it's methyl propanoate. It depends which acid you've used. So if you use butanoic acid, it will be butanoate, methanoic acid, methanoate. And the anoate just means the C double bond O, COO. Would you need to draw these in the exam? Really good question. So all the examples that I've seen, apart from CIE, I'm not sure if any of you are doing CIE. It's quite an old exam board. Not many people will do it anymore. So if anyone's doing the CIE exam board, you do need to be able to draw them. But the other exam boards only require you to be able to draw ethyl ethanoate, which I drew out yesterday. I'll draw it out again today. So ethyl ethanoate just looks like this. So this is ethyl ethanoate. So 2 carbons come, this would be from the ethanoic acid, which produces ethyl ethanoate, and this would be from the ethanol, the alcohol. So that's ethyl ethanoate, which you need to be able to draw. Okay, great. So that's a recap of everything we covered yesterday. So now the new content. So you may remember that we covered how we make alcohols yesterday. Does anyone remember, apart from what's on the screen with fermentation reactions, another way that we can make alcohols that we covered yesterday? It has something to do with the reactions of alkenes. Does anyone remember? How do we produce an alcohol? Excellent. So an alkene will react with steam or water to produce an alcohol. Excellent. Well done, everyone. So ethene and steam will produce ethanol. Now, the problem with that is that ethene comes from crude oil, and crude oil is a non-renewable source, and it causes global warming from the carbon dioxide that's produced as we burn or fractionally distillate crude oil. So one of the reasons we don't like producing ethanol is because that it's from crude oil, and that's a non-renewable source. So another way that we can make ethanol, which doesn't use a non-renewable source, is by fermenting sugars with a yeast catalyst. So the actual reaction is glucose, and it produces ethanol and carbon dioxide. So we're mixing glucose with a yeast catalyst, and over a long period of time, usually over a couple of days, ethanol and carbon dioxide are produced. What's really important is that when they are produced, obviously in your products, you will still have some yeast catalyst in there, because remember, the yeast catalyst isn't just going to disappear. And yeast tends to be a solid. So what we can do is we can filter that out, and that will leave us with ethanol. But hopefully you also remember that if we want pure ethanol and we want to separate it from anything else that's there, usually water, we do fractional distillation. So fractional distillation. So the 2 ways that we need to get ethanol to be pure when we do fermentation is, first of all, filtration to remove the yeast, and then fractional distillation to remove any water. And that's because the glucose tends to be dissolved in water. Okay. This is just the symbol equation for it. So if you do biology, hopefully you know that's the symbol equation for glucose, so C6H12O6. It's aqueous, which means it's dissolved in water. The ethanol that's produced is also aqueous, so it will be dissolved in water. So that's why we do fractional distillation. So if you remember, a couple of weeks ago, we went through fractional distillation to separate ethanol and water, and that's why we do it, to get pure ethanol. And we can see that's ethanol. There's 2 carbons there with 1 OH group, which is what we expect. And then carbon dioxide is produced. What's the test for carbon dioxide? Does anyone remember? How could we test if we've got our carbon dioxide there? Excellent. Yep, lime water. So it turns lime water cloudy. Excellent. Well done. And just as a use of alcohols, so they can be used as fuels. We'll go over that in the next slide, why they can be used as fuels. But the other thing is they dissolve a lot of things. So things like nail polish removers will tend to have some kind of alcohol in them because they dissolve things. So, and that's because they're aqueous. So they're quite good at removing stains and things like that. So that's some of their uses. They can be used as fuels, and they can dissolve things. Excellent. Any questions on fermentation at all? So remember, the 2 ways we make ethanol is through fermentation, which is glucose mixed with a yeast catalyst. Over a couple of days, it will produce ethanol and carbon dioxide. Or if we want to use a non-renewable source, we use crude oil, we get ethene and react it with steam, which we went through yesterday. So any questions on that at all? No? Okay. So I'm sure you're all a bit fed up of combustion reactions now because we've covered them with alkanes, alkenes, and now alcohols. But I promise this is the last time we're going to look at combustion reactions, and it's the combustion of alcohols. These ones are nice and easy. All alcohols undergo complete combustion. So if you remember alkanes, the shorter alkanes, remember when they've got less carbon atoms in them, they will tend to also undergo complete combustion, whereas the longer alkanes will undergo incomplete combustion. Alkenes, we covered yesterday, all undergo incomplete combustion, and alcohols, which we're looking at today, all undergo complete combustion. So if you can separate those out, that'll be nice and easy to remember, hopefully. So it's exactly the same as all other combustion reactions. When it's complete, we produce carbon dioxide and water, and that's why they're good as fuels. So remember, one of the core kind of properties of fuels is that they need to be able to burn well and produce carbon dioxide and water. So they're used in spirit burners and fuels. So someone's just asking me, is ethanol is ethanol the same as alcohol in a biological way? So most alcohols are made from ethanol. So yeah, most alcohols are made from ethanol. That's the starting product, if you want, or starting reactant. So we've got propanol and oxygen producing carbon dioxide and water. As I said in the exam, the hardest thing to do is just to balance these equations. But if you remember what I've been saying all week, start with carbon, then do hydrogen, then do oxygen. We've got methanol and oxygen. So let's do one example because I know we've done loads of combustion reactions. So let's do butanol and oxygen. So butanol plus oxygen will produce CO2 and water, carbon dioxide and water. What's the chemical formula for butanol? If you can do it in this format, that would be great. So what's the chemical formula for butanol? Okay, CH3, CH2, CH2, CH2OH. Excellent. Yep, well done. So if I'll write that out. So if you imagine it, I'll draw it out actually. So if you imagine it's drawn out, so we've got our CH3, CH2, CH2, the final carbon, CH2, the fourth bond is OH, which is our alcohol bond. Excellent. So that's butanol. It will react with oxygen to produce carbon dioxide and water. So if we try and balance that equation, so just remember what I'll do now to help you balance it is I will write it as you're maybe used to. So C4H9OH plus oxygen O2 will produce CO2 and H2O. Okay, so let's start with the carbons. There are 4 carbons on the reactant side, so we need to put a 4 on the product side. If we then look at our hydrogens, there are 9 plus 1, 10 on the reactant side, but 2 on the product side. So put a 5 here. But we're going to run into a problem now because hopefully you're going to see what happens to the oxygens. So if we have a look, there are now 8 plus 5, which is 13. So now if we have a look though, we've got 1 here. And then what does that mean that this needs to be? So if there are 13 over here, so 8 plus 5, 1 here, what does the number in front of the oxygen need to be? 6. Excellent. So this is one of the ones where you don't need to double up. It's just important you remember there's an oxygen over here. So yeah, well done everyone that tried to balance that. So you can see the carbons, the hydrogens and the oxygens are all balanced there. So as I said, this is the last time we're going to look at combustion reactions. We've looked at them quite a lot this week. Just remember, complete combustion, carbon dioxide and water is produced. Incomplete combustion, you're either going to get carbon monoxide, so CO, or carbon and water. So water is always produced. And the ones that undergo complete combustion are the alcohols and shorter alkanes. The ones that undergo incomplete combustion are alkenes and longer alkanes. Great. Any questions on combustion reactions? As I said, I'm not going to come back to it because we've covered it quite a lot today. Not today, sorry, this week. Great. Okay. So the next thing then we're going to look at is one of the reactions of alcohols. And I'm going to say this is an AQA topic only. None of the other exam boards seem to have these reactions. It's just an AQA topic. There are combustions of esters, but you don't need to know them. You'll learn about it at A level. So sodium here, so alcohols react with sodium to produce sodium alkoxide and hydrogen. I'm just going to remind you this is an AQA topic, so if you're not doing AQA, you don't need to know about this. So what I mean by alkoxide is, if you have a look at the first example, sodium will react with an alcohol, specifically butanol, to produce sodium butoxide and hydrogen. What would we see then in this reaction? What would we see if we did that reaction? Bubbles, yep, effervescence, bubbles, fizzing, any of those answers would be great because of the hydrogen produced. So remember, whenever hydrogen is produced, you tend to see bubbles, effervescence, or fizzing. Great. And the formulae you would not be expected to know. So this is the formula here of sodium butoxide. But if you do want to know how we derive it, it's just your butanol without the H. So where your H would be, sodium takes over. So if you look here, we've got our CH3, CH2, 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 which is our but, and then the alcohol, the OH group, exactly the same here. So 4 carbons, the O, but the H has been replaced by the sodium. So that's how you do the formula. You just replace the OH in the alcohol bond with ONA, and then hydrogen is produced. So if we look at sodium and ethanol, we get sodium ethoxide and hydrogen. So what if I said we did sodium and propanol? What would be the products? Sodium plus propanol. What would be the products? Any ideas? Excellent. I've had a couple of correct answers so far. Yep. So sodium propoxide plus hydrogen. Sodium propoxide plus hydrogen. And if you're wondering how to write that, so we would do sodium reacting with propanol, which is CH3, CH2, CH2OH. It will then produce sodium propoxide, which, as I said, CH3, CH2, CH2O, and this H here is replaced with an Na and then hydrogen. And they all pretty much follow the same suit. So you're just going to put 2's in front of everything. And the reason for that is because of the hydrogens and balancing those out. So if you want me to go through that, if we have a look, there are 3 carbons here and 3 carbons here. So our carbons are all balanced. Then we look at our hydrogens. On the reactant side, there's 3 plus 2, which is 5, plus 2, which is 7, plus 1, which is 8. So there are 8 on the reactant side. On the product side, 3 plus 2, 5, 6, 7, 8, 9. So that means we need to make it even somehow. If I put a 2 here, that's not going to make it even. The problem is this molecule. So to make it even, I have to double this. And then if I double that, that means the carbons have doubled, so I need to double this. And again, now let's look, and we can see that I've got 2 sodiums, so that means I need to double up the sodiums. And then if we have a look, it should all be balanced now. Potentially we need to put something in front of the hydrogens, so let's just check. We know our carbons are balanced. Our hydrogens at the moment are 3 plus 2, which is 5, plus 2, which is 7, plus 1, which is 8, times 2, 16 now. And if we have a look here, we've got 3 plus 2, which is 5, plus 2, which is 7, times 2 is 14, plus 2, 16. So everything is now balanced. The name of this reaction is just alcohol with sodium. There's no specific name for it. It's just alcohols reacting with sodium. Any questions on those reactions then? As I said, only AQA topic there, so it's not Edexcel or OCR or CIE, it's just AQA. Any questions at all? The main exam questions I've seen for these questions basically ask you what you would see. So that's why I asked you, but you're right, all of you that said effervescence or bubbles, exactly, you would see that. If you're wondering, the sodium butoxide or propoxide is aqueous, so it will dissolve, and that therefore means that the solution you're left with will be colourless. So it will dissolve, so the solution you're left with will be colourless as well. So that's another property that you could talk about. Okay, let's move on to the next reaction then. So these are oxidation reactions. These are in all the exam boards. And essentially what's going on is that if alcohols are oxidized using an oxidizing agent, a carboxylic acid and water is produced. Any ideas of what oxidizing agents are? Can you name any oxidizing agents? Any ideas? Good. Yep, oxygen is an oxidizing agent. Anything else we can think of? Heat isn't an oxidizing agent, unfortunately. So that would be oxygen in the air from heat, but anything else? So things like potassium permanganate, manganese oxide, they all tend to be oxidizing agents as well. In an exam, they wouldn't expect you to specifically know about oxidizing agents as such. You would just, if they might tell you that something is an oxidizing agent, and then you need to know that when an alcohol reacts with an oxidizing agent, you essentially form a carboxylic acid and water. So if we have a look at the first reaction, we've got ethanol, which is CH3CH2OH, reacting with an oxidizing agent, and that is how you denote an oxidizing agent. So you say that there's oxygen in there somewhere, and it's denoted like that. So the bracket. It then produces ethanoic acid, so CH3COOH. Remember, the COOH is the functional group for carboxylic acids, and water. The second example is propanol, so CH3CH2CH2OH, propanol, again with the oxidizing agent, then producing propanoic acid, so CH3CH2COOH, and water. Someone's asking, are we doing a quiz? As I mentioned at the beginning, today there is no quiz because I want to focus on exam questions. I think that's most important for today. Someone's asking, why is this 2O but not O2? That's because, remember, oxygen goes around as a gas, but a lot of oxidizing agents do not go around as a gas. So potassium permanganate is not a gas. So we put it in as 2O like that, and we say that there's oxygen in there somewhere, but it's not necessarily as a gas, like, for example, in oxygen, which would be O2. If in a question they tell you ethanol reacts with oxygen, then you need to put O2. Because don't forget, oxygen is still an oxidizing agent. But if they say an oxidizing agent, you do this, the square brackets around the O. Any other questions on that? We'll do a couple of examples as well, but any questions on the oxidation of alcohols? Okay, so let's do butanol and an oxidizing agent. So what's the chemical formula for butanol? So butanol plus our oxidizing agent. What's the chemical formula for butanol? Any ideas? Good. Yep, CH3, CH2, CH2, OH. So CH3, CH2, 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 OH. Okay, that's butanol. Then our oxidizing agent. For now, I'll just do this so we can balance it. It's then going to produce what? What's going to be produced when we react butanol with oxygen or with an oxidizing agent? Any ideas? Yep, good. Butanoic acid and water. So butanoic acid is CH3, CH2, CH2, COOH. Remember, that is the carboxylic acid bond, and water, H2O. So if we try and balance that now, so first of all, let's look at our carbons. There are 4 carbons on the reactant side and 4 on the product side, so they're balanced. The next thing is hydrogens. 3 plus 2 is 5, 7, 9, 10. So we've got 10 on the reactant side. On the product side, 3 plus 2 is 5, plus 2 is 7, plus 1 is 8, 9, 10. So there are 10 on the product side. And then if we look at our oxygens, there's 1 plus 2 on the reactant side. On the product side, there are 3. In order to make it 3 on the reactant side, we put a 2 here. So all of these reactions will have 2 oxidizing agents, and that will be a fully balanced equation. Any questions on that one? If not, let's do methanol plus an oxidizing agent. So what's the chemical formula for methanol? So methanol. So remember, that's the first alcohol. Good. CH3OH, so CH3OH is then going to react with our oxidizing agent. What's it going to produce when methanol reacts with the oxidizing agent? Good. Methanoic acid and water. Excellent. Well done. Someone's asking, what does CH stand for? CH is carbon and hydrogen. So remember, all of these are, well, the alcohols aren't, but most of the organic chemistry we've looked at are hydrocarbons, which means they're produced from only hydrogen and carbon. Alcohols aren't because they've got oxygen in, neither are carboxylic acids or esters. But basically they're made from carbon and hydrogen and oxygen alcohols. So the CH is carbon and hydrogen. Good, so methanoic acid. So be careful when you're writing methanoic acid, have another go. I've only had one answer for what the chemical formula for methanoic acid is. And so far we've not had a correct one. So any ideas, what's the formula for methanoic acid? To the person that's tried, have a look at how many carbons you've put in. Good, okay, I've had one correct answer. Any other answers? Methanoic acid, what's the formula for methanoic acid? Okay, so methanoic acid will only have one carbon in. So I'll draw this out just to help make sense. So because it's only got one carbon in, and we need the double OH bond, that means there can only be one hydrogen here. So the formula for methanoic acid is HCOOH. So HCOOH. Sorry, that was supposed to be written out. So methanoic acid. And what's the second product? Excellent, water. So plus H2O. And then if we try and balance it again, if we look at our carbons, there's one here, one here. If we look at our hydrogens, 3 plus 1 is 4. 1, 2, 3, 4. So the only thing that's going to be not balanced is oxygen. There's 2 on the reactant side, but there are 3 on the product side. So to make it 3, we just put a 2 in front. Someone's asking, can you show how to balance equations? Yep, I've been showing as I go along. So what's really important is that you always start with the carbons, then the hydrogens, then the oxygens. So you count how many carbons on the reactant side, then you balance that on the product side, then you count the hydrogens on the reactant, you balance that on the product, and then you count the oxygens and balance that. So if you go in that order, you won't make a mistake. Okay, any questions on oxidation reactions? So far we've looked at the reactions with sodium and oxidation. Any questions on that at all? Okay, great. So the final thing I want to look at today is carboxylic acids. Someone's done, have you done in past webinars balancing equations in depth? Yep, so about 2 weeks ago when we started quantitative chemistry, I did a session where I spent about 20-25 minutes on balancing equations. So yeah, if you go back to there, you can see it. Otherwise, this week we've been balancing equations all week, so you can have a look there as well. Do alkenes and alkanes react with oxidation agents? So it's a very good question. They tend to react with oxygen to do a combustion reaction. So they don't tend to react with oxidation agents in the same way that alcohols do. Okay, so this slide is quite busy. And the reason it's busy is because I'm not going to go through this in detail because we've covered this in previous webinars. It's just to show you that carboxylic acids have the same properties as acids. So someone's just asking me to go back to oxidation reactions, so I'll just go back to that. So we looked at acids and alkalis when we did neutralization, but specifically the properties of acids carboxylic acids have because they are acids. So if we go and have a look first, they dissolve in water to form acidic solutions of pH less than 7. So remember, on the pH scale, acids are less than 7, alkalis are more than 7. The second property of all acids is that they react with metals to form a salt and hydrogen. So when we looked at acids, we looked at the reactions of acids. So for example, ethanoic acid reacts with sodium to produce sodium ethanoate and hydrogen. What would you see in this reaction when it reacts with metals? These reactions, what would you see? So I'll tell you there are two things you'd see. Good, so you see bubbles forming from the hydrogen. So effervescence, yep, what else? If I tell you that the sodium ethanoate dissolves, what do you think that means then? What else would you see? A colourless solution, excellent. So you'd see effervescence from the hydrogen that's produced, and you'd see a colourless solution, excellent. So just like all acids, carboxylic acids react with metals to form a salt and hydrogen. So sodium ethanoate and hydrogen, calcium propanoate and hydrogen. What if we had methanoic acid reacting with potassium? What would produce? So methanoic acid reacting with potassium, what would be our two products? Someone's asking, is a carboxylic acid an alkane? Nope, carboxylic acids are completely different. Good, potassium methanoate and hydrogen. Well done to everyone that answered that. So potassium methanoate and hydrogen. So the salt produced would be potassium methanoate. Excellent, well done. Okay, the second reaction of acids is that they react with bases. So remember that alkalis are bases dissolved in water. So these sodium hydroxide and potassium hydroxide are technically alkalis, but bases is the correct word for anything that has a pH greater than 7. So they react with bases to form a salt and water. Again, that's basically a neutralization reaction. So methanoic acid reacts with sodium hydroxide to produce sodium methanoate and water. It's exactly the same as what we've done here, but instead of hydrogen being produced, we produce water. So what if I said we had ethanoic acid plus magnesium hydroxide? What would be produced? Remember, the hydroxide makes it alkaline. It's got that OH minus. So the OH makes it alkaline. In ethanoic acid, we have a H plus, which I'll show you in just a second. What would be produced if we reacted ethanoic acid and magnesium hydroxide? Good. Magnesium ethanoate and water. Excellent. As I said, I'm not going to dwell on this too much because these are just the properties of acids. I just want to show you that it's exactly the same with carboxylic acids. And the final one is they react with carbonates to form salt, water, and carbon dioxide. How could I test for the carbon dioxide in this reaction? And how could I test for the water? So we went through the tests of water this week, but how could I test for carbon dioxide and how could I test for water? Good, so lime water for carbon dioxide, it would turn it cloudy. The burning splint test is for oxygen, not for carbon dioxide. What about water? How do I test for water? Good, so copper sulfate. So you take anhydrous copper sulfate, you add water to it and it turns blue. So we looked at the reaction of that. I showed you a YouTube video last week on that. And the other one you can look at is cobalt as well, which goes from blue to pink. So cobalt paper will go from blue to pink when you add water to it. Excellent. So they're the reactions of carboxylic acids. As I said, not going into it into too much detail, so you might feel like I've gone over it quite quickly, and that's because they're just the reactions of acids, which we've covered before, so it's nothing new. I just wanted to show you that they are, these are the reactions that carboxylic acids also undergo. So the final thing we just need to look at then is why are carboxylic acids weak acids? And this is a higher tier topic, so if you're not doing the higher tier exam, you don't need to focus on this too much, but it's quite interesting, I think, anyway. So if we just look at this reaction here first, the reason, first of all, carboxylic acids are acids is because they dissociate or they break up into H plus, CH3, CH2, COO minus. So remember that carboxylic acids have this group here. So what happens is that when we form a carboxylic acid, they will tend to break up to have your COO bond, which has a negative charge, and a H plus bond, H plus ion. And remember that acids have this H plus ion. The reason that carboxylic acids are weak and not strong is because if you can see that this reaction is reversible, we've got the reversible sign there, the position of equilibrium tends to lie on the left-hand side, so over here. And what that means then is that there's not much H plus and CH3, CH2, COO produced. And the reason for that is because the equilibrium lies over here. So the reason it's a weak acid is because there's not much H+. So a strong acid will have lots of H+ ions. And that's basically what this box is saying here. It's saying strong acids ionize completely, which basically means break up into their ions completely, whereas weak acids do not. In carboxylic acids, most of the molecules stay as they are, i.e. they stay as a carboxylic acid, and only a small proportion will ionize into H+ and CH3, CH2, COO. So a reversible reaction takes place in which the position of equilibrium lies over to the left. So the reason carboxylic acids are weak is because the position of equilibrium is over here, whereas if it had been over here, which is what happens in most acids, so for example, if we think about hydrochloric acid, that is a really strong acid, it dissociates to H+ and Cl-. And that's why a carboxylic acid solution has a higher pH. So remember, higher pH means that it's closer to neutral. So it might have a pH of, for example, 5, whereas hydrochloric acid might have a pH of 2, making it much stronger. And that also means that they have a lower concentration of H+ ions. Any questions about that? So as I said, it's a higher tier topic, but it's all about the dissociation of the ions and ionization. Any questions? Okay, great. So if that all made sense, that's it for the content that I wanted to cover today. So I thought we'd just make sure we're happy with yesterday's content and today's content, and then we'll go over some exam questions. So the learning objectives from yesterday were the combustion reactions of alkenes, which I've covered today. Remember, I reminded you that they're incomplete, which means that usually we produce carbon monoxide and water, or carbon and water. And they will tell you in an exam question that all the combustion reactions of alkenes are incomplete, and that's why they are not useful as fuels. Know the reactions of the first 4 alkenes with halogens, hydrogen, and steam. So we remind ourselves of the steam reaction today produces alcohols. Does anyone remember what happens when we react an alkene with hydrogen? What's produced? An alkene with hydrogen. Anyone remember what's produced? Good, excellent, alkane. So for me, I think I said yesterday that these are the ones I like the most because it makes sense to me. Alkenes have 2 less hydrogens than alkanes. So if we add in hydrogen, we form an alkane. Good, and what about halogens? Does anyone remember what happens, or what I said yesterday is the product when we react with halogens? Yep, good, dihalogen alkane. Good, dihalogen alkane. So dihalogen alkane. Excellent, well done everyone. So they were the 3 reactions that we covered yesterday. If you want to go over those in more detail, head back to yesterday's webinar. Be able to draw the first 4 alcohols. So I've drawn lots of those today, so hopefully you know what they look like, but we're looking for the OH group. Carboxylic acids, again, I've drawn a couple of those today. So the COOH group, and remember, like so it's a double bond there. And then ethyl ethanoate, I also drew that earlier. So it's an ester, so you need to be able to draw that. So that's what we covered yesterday. So we looked at the reactions of alkenes and the structures of all of these and the combustion reactions. Any questions on that at all? Anything that was confusing that you didn't manage to ask yesterday that you want to ask now, please ask it. Okay, and then today we looked at the combustion reactions of alcohols. So remember, they are always complete, which means that we produce CO2 and water. We need to know the reactions of alcohols with sodium. So what happened when we produced sodium? What were the products when we reacted with sodium? Someone's asking me what reaction makes ethyl ethanoate. So it's an alcohol plus a carboxylic acid. An alcohol plus a carboxylic acid. So if I just go back to this slide here, right at the beginning, we recapped what we covered yesterday. So esters are made from the reaction of an alcohol plus a carboxylic acid. Good, so everyone that's giving me the answers to the question for the learning objective here, yep, so it's sodium alkoxide plus hydrogen. Good. And what about oxidation reactions? What are produced when we oxidize our alcohols? What's produced when we oxidize our alcohols? Good. Carboxylic acids. Carboxylic acids. Excellent. So carboxylic acids, and then we've explained why carboxylic acids are known as weak acids, and it's because they do not dissociate very well. So do not dissociate or ionize very well, and the position of equilibrium lies towards the left. Okay, so obviously it's Q&A time now, so if you've got any questions, send them into the Q&A function or the chat box and I'll answer them, but we'll do exam questions as well. So ethanol burns in air. Use the correct answer from the box to complete the word equation for that reaction. So alcohol doesn't turn into vinegar as such, it's just a big proportion of vinegar. So vinegar is made from water and ethanol. And so it's not specifically ethanol, it's ethanoic acid, sorry. So do you remember how we make ethanoic acid from ethanol? What do we need to do? So yeah, oxygen's the correct answer for part A for those that have answered that. So does anyone remember how we make ethanoic acid from ethanol? What do we need to do to it? So we need to oxidize it. So we need to put an oxidizing agent in there. And when that happens, we produce ethanoic acid. So I've kind of given the answer away for the second one, but ethanoic acid is in vinegar. And so when we oxidize our ethanol, we get ethanoic acid. So most of vinegar is made from water and ethanoic acid. And the answer here was oxygen. Okay, which over there shows the functional group of a carboxylic acid? Which one shows a functional group of a carboxylic acid? A, B, or C? At the moment, these are AQA questions. We're going to be doing a range of exam questions we've got from all the exam boards. Good, A, B, or C? Everyone that's given me answers so far, you're correct. Good, C. Well done. So we're looking for the COOOH bond. So COOOH bond. Okay, ethyl propanoate is produced by reacting ethanol with propanoic acid. What type of organic compound is ethyl propanoate? What do we think? Good, ester. Excellent. Well done, everyone. It's an ester. Okay, let's go on to the next question. This is now OCR. So the alkenes are unsaturated hydrocarbons. They form a homologous series, the members of which have similar chemical properties. All the alkenes have the same empirical formulae. State the empirical formula. So if you were here yesterday, I did actually give the answer to this question yesterday. I don't want the formula that you use to calculate what an alkene is or what the number of hydrogen atoms is. I want the empirical formula. So the empirical formula is the simplest ratio. So if I write out a couple of alkenes, so for example, C2H4, that's ethene, propene is C3H6. So we're thinking about the simplest ratio. What do we think? What's the simplest ratio? Excellent. Someone's given me the correct answer. I'll wait a couple more seconds, see if anyone else can get it. So we're looking for the simplest ratio of these atoms. So what's the simplest ratio? C4H8, for example, the simplest ratio of the atoms. That's what the empirical formula is. Good. Okay, most people have given me answers now. It's CH2. Excellent. Well done. So what you can see is that there's always one carbon doubled with hydrogen. So if we take this, it would go to CH2 by dividing by 2. If we divide by 3, CH2. If we divide by 4, CH2. So that is the empirical formula. Why is the empirical formula for the alkenes the same? Someone's saying, isn't it C1H2? Yep, but remember we don't write ones, so it's CH2. Why is the empirical formula the same for all the alkenes? Any ideas why is it the same? So because they have the same functional group, that means that the empirical formula is the same for all the alkenes. Remember, the general formula is CnH2n, so they all come from that, and that means that you'll have the same empirical formula for all the alkenes. It's always the same ratio. Okay, so alkenes can be oxidized to carboxylic acids by boiling with aqueous potassium manganate. Pentene oxidizes to one acid and a second acid. Which acids are those? So can we name them? What's the first acid and what's the second acid? Someone's tried to give me an answer for the first acid already. Well done. What's the first acid? You were that wasn't correct though, the first acid. The person that's given me an answer. So any ideas? First acid and second acid. Look at the number of carbon atoms. Good. Okay, so the first acid, I've had 2 correct answers so far. Good, it's pentanoic acid. Sorry, not pentanoic acid, propanoic acid. So there's 3 carbon atoms, so it's propanoic acid. Propanoic acid. What about the second one? There are 2 carbon atoms, so which acid is that? Excellent, it's ethanoic acid. Well done, everyone. Ethanoic acid. So we've got propanoic acid as the first one, ethanoic acid as the second one. So remember, alkenes will oxidize to produce carboxylic acids as well. Okay, so complete the following equations for the addition reactions of propene. So what happens, or what is produced when we react this alkene with bromine? Someone's asking, isn't it propane ethanoate? No, these are all carboxylic acids here. So the ethanoate molecule is CO. That's the ester bond. There's no ester bond in those, it's carboxylic acids. So what's the first one? Any idea? I want the equation, so the chemical formula, not the written words. So I will draw out this equation because we did it yesterday. So we've got CH3, CH2, double bond CH2. And remember, we want to count that there are 4 bonds. This is propene. There are 3 carbons. It's an alkene because we've got a double C bond. It's propene. It's going to react with bromine. And if you remember what we covered yesterday, the bromine breaks that double bond. So essentially, we end up with an alkane, or dibromoalkane. So it will be propane. And where the double bond is, in its place, bromine will replace it. So we get H3. I've just realised that I drew too many bonds there as well. There you go. H, Br, H, H, Br. So any ideas what we call that then? So the good, it's dibromopropane, CH3, CHBr, and CH2Br. The way that I like to write it out is just, you don't need to do the CH3 thing, you can just do C3, H6Br2, like so. Any questions on that at all? Okay, what about the next one? So we've got another alkene reacting with water. What happens when alkenes react with water or steam? What's produced? What happens when alkenes react with water or steam? What's produced? Or what's produced in this case then? So we've got propene again reacting with water. So what would be produced? Yeah, alcohol. So which alcohol specifically then? So we've got propene reacting with water to produce which alcohol? Someone keeps saying propane ethanoate. That's an ester. It's not going to produce an ester. It's going to produce an alcohol. Yep, good. Propanol. So propanol will be produced. Excellent. Well done. Okay, this is now an Edexcel question. So the reaction to make ethanol from sugar is known as what? Combustion, decomposition, or fermentation? What do we think? I'll just wait for a couple more answers. The reaction to make ethanol from sugar is what? Combustion, decomposition, or fermentation? What do we think? Someone's asking me what's an ester and an alcohol. Good question. It's about the bonds that you have. So in an alcohol, you have an OH bond. In an ester, you have this bond here. So if you go back to yesterday's lesson, we cover the structures in lots of detail, and we also did it a bit at the beginning today. Good. So the answer to this question is fermentation. Well done. Do you remember in fermentation, what's also given off? So we get glucose, reversible reaction, produces ethanol and one other product. Does anyone remember what that other product was? The clue is that there's lime water there. So why would there be lime water? Good, it's carbon dioxide. Excellent. So we get ethanol and carbon dioxide produced when we ferment it. Okay, so the reason for this then is the lime water turns what? And this happens because of what? Good, the lime water turns cloudy because, why? Why does it turn cloudy? It doesn't turn colourless, it turns cloudy. So lime water turns cloudy. Good, when carbon dioxide is present. Excellent, well done. Okay, ethene is produced when hydrocarbons are cracked. So this is a bit of a reminder of what we covered on Tuesday. Someone keeps sending colourless. No, lime water turns cloudy, it does not turn colourless. So tick 2 conditions needed to crack a hydrocarbon. So does anyone remember, what do we need to crack a hydrocarbon? The 2 conditions needed. So remember there were 2 types of cracking we looked at. We looked at steam cracking and we looked at catalytic cracking. So this question is essentially asking about catalytic. Good. So high temperature in the presence of a catalyst. Excellent, well done. So temperature and catalyst. How do we draw ethene? Which bonds are missing there? What do I need to draw in? Okay, someone has said double carbon bond and the CH single bonds. Excellent. So you need a double carbon bond because it's an ethene, it's an alkene. Oh, let me make that a bit smaller, sorry. So double carbon bond and then single bonds like so. Okay, great. Well done. We'll do one more question then. What are the main steps needed to obtain pure ethanol from the mixture produced after 3 days? So I covered 2 steps that we need to do. So remember, when you make ethanol, you've got glucose reacting with yeast, which is the catalyst. It produces ethanol dissolved in water and carbon dioxide. So what were the 2 steps I went through right at the beginning that you need to do to get pure ethanol? Does anyone remember? It's one followed by the other. So the clues I've given you are that there's a catalyst and that the ethanol is dissolved in water. Good. The first one we need to do is filtration, and that's to remove the yeast. So filtration to remove the yeast. Good. What about the second step? So filtration to remove the yeast. What's the second step then? Fractional distillation. Excellent. Well done. So fractional distillation, and the reason for that is to boil off any water so that we get pure ethanol. So it's to remove water, essentially. Good. Excellent job today, everyone. Really well done. I hope you enjoyed the lesson. I will see you again next week. So we have 4 lessons next week. And as I said, we'll be looking at polymers for the first 2 lessons. And then the second 2 lessons, we'll be looking at electrolysis, which I know a couple of you have asked, have said that they wanted to know. Before we end, someone's just given a joke about potassium. 2 chemists walk into a bar. The first one says, I'll have some H2O. The second one says, I'll have some water too, but why'd you order it like that? We aren't at work. The first chemist excuses himself and weeps in the bathroom. His assassination plot has failed. Okay, thank you for that joke. Take care, everyone, then. Have a nice weekend, and I will see you on Monday at 9:45.
Thanks, Aman. And just a reminder that the sessions we have for the rest of today are English literature coming up at 11, then maths and biology this afternoon. So I'm sure we'll see some of you in those sessions later, and we'll see the rest of you in the next chemistry session next week. Bye.